So as I was telling you, right? So I bought the book, which is recommended by JetBrains, yeah, for Kotlin design patterns, and not many books out there covering all design patterns in Kotlin. Because I mean, we want to learn Kotlin, and we thought, I mean, this is the best way to learn it because by looking at every single design pattern, we will be able to accept, I mean, use the Kotlin features and such, So we want to practice Kotlin more in a better way to use a design pattern so that, I mean, we can learn the design pattern on the other hand. So that's what we have started doing, from learning the basics of Kotlin and then start applying these design patterns. So we are here at the moment. So we finished with the creational patterns. So we looked at all these as examples as I was having them recorded in the YouTube videos as well. So we can have a look at them. Sorry if there are any poor quality or not much explained or anything like that, because I'm also new to putting stuff on YouTube. And also, doing live coding with a group, so I'm learning a lot, doing these as well, so other skills as communicating, teaching, and, doing live coding and stuff like that. So, yeah, but here, we thought, this is just for us, to come and be a family and, help each other and, make mistakes, learn from mistakes, and, teach others as well, so if anyone has anything to teach, this is the place I'm seeing as, because for all these years I've been in the industry, I've never formed a group or not been in a group like this to keep it quite close, as we take care of each other, So yeah, so this is the first time I'm in a group that I can come close to you guys, as well as I can feel like there is somebody I can speak to if anything, if I don't
Yeah,
understand
sure.
anything or this and that, so that's the main intention of forming this group, to be a family. So Saturdays and another day maybe, we come along, speak about certain things, which we didn't understand at work, or if there is a challenge at work or anything like that, to boost our performances, to help us, improve well and perform well at work. Because I've seen Italians and Spanish, they have lots of group like this, and they are, and I don't know, in Indians as well, Nila. I've seen some India in some developers from India, they have a group and they self teach each other. But because I've been here for most of my time, and I'm from Sri Lanka, we didn't have a group, but now we're trying to form it in this way. What do you think? Anything you can add in, or you have similar ideas, and Nila?
Yeah, I'm just fine with this. I came here to learn from you guys.
Yeah, and teach us as well. If you're learning something, come and teach us, like the other day. So we met at DroidCon, guys. Nila and me, we met at DroidCon, and the other day, as I was telling you, about the composed performance monitoring. So I went ahead and checked the blog post the guy has written. And as he said, he is using a profiler. This is to Nila. So ignore, guys. Sorry about that. I just want to quickly tell her, because we were discussing about, how to monitor performance in composables. I'll tell you
Yeah.
more, Jason. Yeah. So
Mhm.
yeah, I was reading the blog post, Nila, and
Okay.
as he was telling, he was using a Profeto profiler, and that's going to come in Flamingo Canary build. Yeah, it's already there. So if you download Canary build, the latest Android Studio Flamingo, which is in a beta at the moment, it's going to come stable soon. We can be able to actually, go to an area where the composables are recomposing and check the performance in a better way, rather than like, we were thinking we check the recomposition count and apply any fixes or anything like that, which is not needed, because of, as he was telling in that talk, it's over optimizing, so we don't want to over optimize because of the recomposition go up, because it could be for the right reasons, So as I was playing with this, the profiler in Android Studio at work, and it's really good. So that's what we
Oh,
actually, yeah,
okay. Yeah, it's very good. I'll try that too.
yeah.
Currently, I'm using the electric eel.
Correct.
I'll try that.
Yeah. I'll send you the link as well. So I was playing with this, and also, some of the days, me and Jason, we are looking at an Android app, so to build it from scratch, with the help of, looking at Android samples, and also, teaching the stuff we don't know. I haven't used Hilt before, so we are learning Hilt and applying that in the project. I don't know how much you know Hilt. Are you using Hilt these days? Nila?
Her internet's probably cut out.
Ah, okay. Right. Okay. Anyway, yeah, just want to quickly tell her those as well, you know. So yes. Okay. Anyway, I'll speak to Neil after this or later. I'll send you the links, you know, which other things, you know, we're looking at and all that. Just want to give you
Okay.
the ground up, you know, so that you can, you know, if you see, I mean, if you see anything that you're using and, you know, want to explain or, you know, where anywhere you get stuck and stuff like that, this is, I mean, we love to see those, you know, because that's the only way I can see that, you know, we can learn extra, you know. Right. Anyway,
Yeah.
so yeah. Okay. Right. So welcome on board, and yeah, let's start then. So as we were looking at these design patterns, right? Um, so we had the behavioral. Yeah, we looked at state the other day, and today, you know, we are going to go to we're going to look at command, and if we have time, let's look at uh, chain of responsibility. Yeah. So these are the two design patterns in the book, right? I was reading. And so let's start with the command then. So the command, it was saying, have you used these design patterns, Nila?
I think no.
Right. Okay. Or maybe you have used them, but you didn't know, you know, which ones are they, right?
Yeah, yeah,
Most of the
yeah,
cases,
yeah.
or
That's
something like
right.
that.
Yeah.
Yeah. Yeah. We
Maybe I
might.
have visited the singleton.
Yeah.
These things I know that.
Yeah.
Yeah, singleton, builder,
Yes. Definitely.
uh,
Yeah.
composite.
Yeah.
Yes, adapter. This some of this.
Yeah. Correct, correct. But yeah, so this is to brush up the design pattern, that what that means and what sort of pattern it brings into the code, as well as, I mean, how to achieve this using the Kotlin features. You know, that's what we are seeing as, you know. So yeah, so today as well, you know, so these I as I was reading, I was brushing up a lot on, you know, I mean, how to use lambdas and stuff like that, right? So today, it's going to be full of looking at how we can use the lambdas in Kotlin to achieve this, you know. So it's quite cool that I was as I was able to, you know, I mean, get my hands a bit more dirty with the lambdas and how they are involved, and you know how they can be used in patterns like this. So I'll show you what I've learned, right? And yeah, you can you know, correct me if there is anything we can improve or add on and stuff like that, right? Okay, so the command, what does it mean by command? So as it says, so we use this thing. So the command pattern, it says, right? So it says if you have an object, right, and you can put in an action. So this action can perform anything in this object, right? It could change its state, or you know, it could change the behavior of the object by changing its states and all that. So there is an action sitting in this object, right? So this action is belonging to this object. Yeah. So the command pattern is saying is the caller can use a command from outside. Actually, you know, this could be outside the system, and you know, this could be the user. So they can use some set of commands to activate this action later or schedule it for another time. So the pretty much, you know, like, I mean, there is an action sitting in this object. They can call this action using a command to run anytime, you know. So that's where these commands are coming in place. You know, the command design pattern is coming in place to use these commands to call an action in an object to run later or anytime you want. You know, so the user has the control calling these commands to activate these actions living in this object. So that's basically what the command pattern is talking about, right? Any questions? You guys happy with that explanation? Any questions, Jason?
Yeah, sorry. What do you mean
Yeah.
by it changing its state?
Yeah, because see this action, say that, I mean, there is a value, right, in this object. And let's say, you know, the value is starting with 0. It's an integer. Yeah. This action is counting, you know, so it's incrementing this value. So when the command comes to say increment now, the value is now going to change to 1, right? So every time this action changes its value in the object, the object state is changing, no? So the states are the values which are
Okay, yeah.
which are kept in this object, right? Yeah, so the state changes because of the action is called by a command, right? So to activate the command or to run the command, to do something with the command in an object, later time, by giving the control to the user, the command pattern will come in place to do that. So we need to have something to apply a command, right? To tell this object to do something.
Yeah.
Like, we command things, we tell, go there, go here, do something, same like that. So these commands are to tell this object to run this action. Yeah. So if
Is
you
that
have
like an event?
sorry,
Could it be called like an event?
yeah. But we call this as commands, because we're commanding this object, right? Yeah,
Okay.
So the way I see it, so if you have an object and there are certain actions we want to run on later, I can use commands, so I can think of using a command pattern. If you look at an example, we will see how we can do this, right? Okay, right. So let's do this then. So we had behavioral. Command. Cool. So the example this was using is so it was saying, okay, so let's I follow the book and I try to come up with an easy example as possible, because the book is sometimes overcomplicating with examples, so this is the easiest example I can come up with, matching exactly like what the book is telling, right? So remember we were looking at the robots, right? So if we have a robot, the robot we can say, it can have an action, it can attack, or it can walk and stuff like that, right? So let's put the action here. So let's say it can walk with certain coordinates, right? X being int and y being Charit. You happy so far?
Yeah.
Cool. Right. Yeah. So the robot can walk. Yeah, I'm going to work it through because I've read the example, but I haven't coded it by myself. So I'm going to do it here too. So help me out. So we're going to do it together, right? So I'm thinking as this is the action, right? So this is the action we want to call later, but not now, right? So so when this is called, let's put a system.println saying I am walking. Yeah. With X and Y. Let's print those as well. Otherwise we don't know which one is doing what, right? So and Y with Y. Okay. Right. So this is the action. Yeah, a robot can walk. Right. Okay. So now what we need to do is we need to think of commands, right? So I will need to, so in my main method, so this is my entry point. Yeah, so this is my main function to call anything in this file. So I should be able to make a value of a robot and call walk, yeah, with everything. Yeah, but I want to apply a command to do it, not just by calling it action itself. I want to wrap it into a command so that every time I call that command, this will be activated. That's the command pattern is talking about anyways, isn't it? As we saw, we need to call a command to tell this object to run the action it has. Yeah. Yeah. So that's the pattern. So once we finish, don't worry too much of it. How this is going to look, because if I know and I've seen how this should be looking, I can picture it. But once we've seen it, once we finish with it, and once you've seen it, then you will be able to see the pattern coming together. And then what we can do is every time when we think of I can do this, then we will just use the same pattern, right? So I'm doing the same now, because I've seen it, I'm applying it now, for this problem I'm thinking as, because I have I can picture the pattern in my head, right? That's what I'm trying to say. So once it's finished, then we will be able to, apply the pattern in other places, which they would match, right?
Yeah.
So yeah, so I know how to apply the command pattern. So I would basically think, I mean, how to use commands here, right? So I would need something called command, right? Before we go in further, there is, right? So in Kotlin, right, there is something called type alias. Nila, have you used them?
Sorry, say it again.
Type alias. This one.
Oh, no.
Okay, good. That, I mean, we can look at this too. This is a very
Yeah.
cool feature in Kotlin, right? So type alias are used to name a type, right? So imagine, I have some types, right? Which I don't know how to name it, right? Mostly used in lambdas, so, okay. So before we go further, even, we need to drill more down into what is a lambda. So what is a lambda? Can anyone tell me?
A function without a name.
Yes, correct. It's an anonymous function, right? Yes. Yeah. So this is a lambda, right? So if I say, if I say val some lambda, its type is, it's not taking anything, not returning anything, then I can do this. So this is an empty lambda, but at the moment, this is an anonymous function, which is empty, but the type is this. This is the type of that lambda, which is L, I'm calling that, right? Remember, we can assign lambdas to a value as well, because they are first-class citizens, right? The functions are first-class citizens in Kotlin. So same like, we can assign an object to a value in Java, we can assign a lambda in this case, which is an empty lambda, to a val, right? That's all I've done. But you can see after the double colon, this is the type of it, isn't it? So what's the type of this lambda? This is the type of that lambda, which is not taking anything. That's why nothing in there, and it returns nothing. So that's why we put it as unit. And there are three, paces we should think of using a lambda. So the three paces I think as, this is me, I have figured it out, like, I mean, how to deal with lambdas, right? The first pace is, defining it, defining its type. Yeah, this is my first thing I need to do. If I need to assign a lambda to a value, right? So the first thing I need to do is tell what type of the lambda this is, right? When I'm saying three paces, the three paces of it, how to define a lambda and use it later, right? You will go through this every single time as I figured out, oh, this is what I'm doing always, because lambda is a big complicated subject for me, because I've never used it this much. Yeah. So as I'm coming from pure Java background, when it comes to lambda and functional programming, I was struggling a little bit. And I'm trying to make it a bit more sense now. Trying to understand, this is what I've been doing all this time, even though I've been using this for the last 2 years, two odd years in the project, I'm not sure about Nila. So you might be using lambdas a lot, right?
Yeah, I'm using, but
Yeah.
as you saying, not completely understanding about lambdas, are just using. If they suggested, then you go with, oh, okay, we can use lambda like that only. But not having a full understanding of lambda.
Me the same. Until I started exploring more, with this book and trying to understand the design patterns and all that, because this is the only way, we can get it, because at work I haven't had this much opportunity, Work is like, oh, how do we do this? Just copy this, paste it, go, get it working, and it's running, done, job done, and we forget it and we carry on. But I never took time to understand, one even more deeper, like, one step closer to one step, how do I say it? Even one step down, yeah. So let's try to understand this fully, here. So that's what we are here for, right? So, and no time restrictions or anything like that. We're not at work, so we're trying to understand this, taking the whole day, right? Yeah. So the three things I'm always seeing when I'm dealing with lambdas is, I would need to tell the lambdas type. Yeah. So this is a value, but I'm defining a lambda as. Charit might be knowing this a lot, because Charit, you've been using JavaScript and Scala and stuff like that, no?
Yeah.
So correct us if we make any mistakes, right? If you don't make sense. Yeah. Have you been using lambdas, Charit?
I have the use in when I use Java 8.
Oh, I
have
see. Right,
Lambda in
right.
CS6 syntax in JavaScript, and also some Python functions there.
Oh yeah, closures, right? Closures.
Yeah.
Yes. So you will find it easier, but I mean, we want to take a step back and we want to understand this fully. That's what I thought. I mean, would be nice to do today, Right. So I'm defining a lambda child, so I'm telling what type is this going to be in Kotlin, right? And once the value is when we are defining a value, we need to initialize it too. So after the equal, we need to say how this is going to be implemented in this case, because if it's a function, we're not assigning a value as an integer or anything like that. So if I say age or something, which is an int, then I will need to assign a value, Oh, yeah. What is it? Yeah. So the same we are doing here. Value, the name of the lambda is L, the type is this, same like here, we say type is integer, and the starting value is that, because we need to start with an initial value, right? When you assign a value. In this case.
That's right.
So, yeah, so it's an empty lambda because it's not doing anything, it's not taking anything, it's not returning anything. But imagine if we right, so this is the first place, telling what type is it, initializing it, and then call it somewhere we want to use it. Yeah, so invoking it, right? So if I want to call this lambda L, I can call this doing this, this is let's give a name. Yeah, this is our lambda. So yeah, this is how I'm invoking it. So when I invoke, everything in this bracket, which is the lambda, actually will run. Yeah, so these are the three places I'm seeing. So first is defining the type. The second one is implementation, or implementation, how I want to implement this, when this lambda is initialized, and then invoking it. Yeah, so which is here, right? But then let's change this to take an integer. It'll immediately break because of we need to pass an integer at the calling at the place when we invoke it. Sorry, so I'll need to say, what is this, x? Yeah, it takes integer and doesn't return anything, so we need to pass the integer here, because of this lambda is defined now as taking an integer and not returning anything. But the implementation is not doing, it's still marked as an empty lambda. So even if you pass 1 inside this lambda, it's not going to do anything. So if you want to do anything, then you will need to do something with it. So if I want to multiply that, oh sorry, so I'll need to say what's coming in. Yeah, sorry. Yeah, so now what I'm saying is, this lambda's type is it takes an integer and doesn't return anything. So that's how we can implement this here, saying it takes something in, which is, you can mark the type here too, which would be an integer. Yeah, and it will multiply that by 2. So if I put 1 in, the output will be, it's not doing anything, it's just multiplying it. But if you want to return the value or result, then change this here, that now it needs to return something. So when I get it, it will be 2. Yeah, there'll be an answer for this, there will be a result for this, which will be multiplying the input x by 2. Yeah, so if I get this value to another thing or something, result or something, the result will be conflicting declaration. Oh, sorry, lambda result or something, then the lambda result will be now 2. Yeah, this will be 2, because of what we are getting out is an integer. Are we good with this so far?
Yeah, I kind of understand it.
Yeah.
Is it a possibility you could
Hmm.
write a normal function and just put the same values inside? Is that all right?
What do you mean by a normal function? Oh yes, yes. Oh, you mean a function? You create a function, yeah?
Yeah.
Called
Yeah, just like
exactly. Yeah, correct. So x being this int input, and then it's going to return an int. Then you multiply so return x multiply by 2. Yeah. Yes. So
right.
yeah, which would be a function, but this is a lambda, right? Because if it's an anonymous function. Yeah.
Yeah. So the fun is taken off, and the lambda is taken off.
Yes, correct. Yes. But what's the advantage? Why can't I have a simple lambda function, a simple function like this, to a lambda? I think, yeah, that's something I don't know too. I mean, I'll need to check it out. That what's the advantage? I think it'd be something to do with the, this thing being an
It's on a single line. I don't know.
No, we can make all these to single line too. We can infer the return.
Oh yeah, that's correct. Yeah.
We can just do this,
Yeah, that's correct. Yeah, you're right. Single line.
Mm-hmm.
What's that called? A single line statement or single line function or something like that.
Yeah. The thing, I mean, yeah, I'll check it out, but this will be something that, I mean, we can check it out. Unless Nila, do you know about this?
Yes, advantage you see lambda, it can assign as a parameter, then pass to another function.
Like we're doing it now here.
No.
Oh yes, I see what you mean. Yes, we can pass it as a parameter into another function. Is that what you're saying?
Okay. Yeah, you can pass the lambda itself, the lambda name.
Yes, but I can also pass a function into another function. It doesn't necessarily need to be a lambda. Sorry, what were you saying, Jared?
Sorry?
What were you saying?
That's like the same.
Yeah. But I think, I mean, if it's an anonymous function, you don't need to name it. It doesn't necessarily need to have a function name. And also, in a collection, they take lambdas, as high order function. So if I have a collection, and where is it? Any collections? Yeah, iterator, for example. Yeah, so I have a list of fruits, right? So fruits, if I can call, filter and all that, right? For an example, if I call filter, this is a lambda, right? So yeah, this is a lambda. It takes a lambda. See that? It takes something in and returns a Boolean. This is the lambda we need to pass in, right? So we can pass a lambda as a parameter here. And if we can pass a lambda as a parameter into another function, which in this case, we're defining this as a function, they call this has a higher order function, but then don't worry about that. I mean, we can be able to pass a lambda as an input type to another function, Yeah, this is functional now. I mean, yes, that's the immediate advantage I'm seeing. But let's read up on that a bit more. Like Charity is also saying, that I mean, you can be able to pass a lambda into a function as a parameter, right? So now I have this to be called in another function. I can call it, and this the type is this. So the lambda itself should be taken an input as integer and will always return your value. Yeah. But what we are doing is we are actually creating a function like this. You see? So I can now call this to can I call this multi, and all I'm telling is do this now. Yeah, this is I'm calling that function into here to do the actual operation. So we can do certain things like that as well, right? Because of this function, is actually returning me the integer I want. So this will return it. So the lambda will be happy with it because of it is returning the integer we want, right? In this case, multiplying it. Yeah. So things like that. So, right. Yeah. So coming back. So the first step is defining the type, which is this. Yeah. The second step is implementation, how and what it should do, what it should implement. This is the implementation details we're saying the lambda should be doing, right? If it's a function, that how the body of it, what it would do, right? And then invoking it at here, right? We're happy with this, right?
Yeah.
Yeah. Cool. Right. So now let's come to type alias. But then if you look at this type, right? How do we call this? It's taking an integer and it's returning an integer. This is when we use the type alias in Kotlin. If you don't know how to call this, and if you want to, if you want to give a name to this so that people can understand this easily, then you can use the type alias. So what we can do is we can have a type alias and call it as anything we want. Something takes an integer and returning an integer. What is it? Some integer handler or something, I'll call it. So that when I read this, I know, yeah, hold on. I know that, this is what we are using, right? Yeah. And now I'll say this is the type here, right? And I would name this that, you see? So this lambda is a type of integer handler, I'm saying. Something that is taking integers and returning. That's what I've named it as, for this. So I can use it here. So when I read this, we can make more sense, by giving appropriate names for that type. You see what I mean? Yeah. So that's where we use the type alias. So if you have a type which you can't find an appropriate name, we can push it to a type alias like that. Yeah. Happy?
Yeah, okay.
Cool. So, Charit, are you happy with this type alias thing? Cool.
Okay.
Right. Okay. Okay. Let's now think, now what we have to do, right? Okay. So this is what I always, this is what I want to show anyway, just to,
Got 1 minute.
Oh, is it? Yeah. If it stops, we will start again, Nila. So that's what we've been doing because the Zoom doesn't give us more time, so it gives us 40 minutes as a session per session, so we'll start again. We start the same link, yeah?
Okay, okay.
Cool. Yeah. So now we want something to call on this thing. We need to, define some commands, as we said, as we started, to let